Hey, what's up, guys? Welcome to my channel. I'm Jack. Today we're going to talk about building a Drupal instance in OpenShift, the reason why we're doing this, and the benefits we're getting out of it. And I'm going to show you how to get this whole thing work step by step. Drupal is a free and open source content management system. OpenShift is Red Hat's Kubernetes platform. You might be thinking, those two do not sound to be related. And that's right. They're not by design to work with each other, but we can make them work as a great couple by following the steps in this tutorial. First, I want to share our story about why we decided to containerize Drupal in our organization. In the past, we have Drupal installed on our on-prem Linux boxes. First, we put it in our middle tier. It turned out with a lot of issues working with the proxy server to get to the internet. Then we put it in our DMZ, and that turned out to be a big problem, as some hackers exploit the vulnerabilities and use Drupal as a gateway into our internal systems. Another unique challenge in our organization is our infrastructure is outsourced to an external vendor, so we're not getting root access on the Linux boxes. It makes the configuration process frustrating. A lot of iterations of supporting tickets with the vendor. At the time we're going to spin up another Drupal instance, our organization had an OpenShift platform ready. So we decided to take a look and see if this containerized option would work for us. The challenges with this Drupal solution is that it comes with several different pieces. For pure PHP solution, you can just do a source to image build. But for Drupal, you have to have a web server to run it. You have to have a database. You need the Drupal software itself and your custom code. So how to put the pieces together and get them containerized? Fortunately, there is an official Drupal image that we can refer to. If you go to Docker Hub and search for Drupal, you'll find the image. If we scroll down and click on the link, we can see the source code of the Docker file in GitHub. We're not going to use this Docker file directly though, because we want to separate our code with the base Drupal image. So we can do an S2I or source to image build, because our source code is supposed to change more frequently than the base Drupal image. And we want to automate the build by taking advantage of the S2I process. But this file is still a valuable source for us to create our own Docker file. I already have my Docker file created. I'm going to go through it with you section by section. The first section is the PHP image we're going to use as a base. In the second section, we're installing some required libraries. You can see I installed some handy tools as well, such as VM, wget, and zip, so that we can use those tools in the container. We're also installing some PHP extensions. For example, since we're going to use Postgres as our database, I'm installing the PGSQL extension. In the third section, we're installing the Drupal Composer. To make this whole thing work, our project has to stick to the Drupal Composer project structure. In the fourth section, we're going to install Drush, which is another important component. We've used Drush command a lot from our manifest. In the next section, we're creating some folders. The app folder is where the site runs out of. The code folder is where we copy our source code into. In the last section, we're overriding the php.ini file, as we need to tune some parameters. So I'm going to use this file to build our image. So the image is built. So I'm going to push it to the integrated repository. If you're not familiar with the integrated repository, please take a look at my previous video on that topic. Now we have the image here in the integrated repository, but we cannot deploy this image into the container directly because this is just a base image. We need to add our source code into it. So what I'm going to do next is to create a Drupal Composer project on my local. So first I'm going to make a directory and switch to it. Then I'm going to run the Drupal create project command. We name the project src. So the project is created. Let's switch to the src folder and take a look at its contents. We don't want the vendor folder as we want to keep our code base small. So I'm going to remove it. We're going to make some other important changes here. Let's switch to the website's default folder. Here we need to create a file, settings.php, based out of the default.settings.php. I need to edit it a bit and add some code. So basically it says, if there is a settings.openshift.php file under the same folder, please include it. Since we don't have this file in our local workstation, and we will have it in our container, this piece of code works for both the developers and the admins, because the developers don't need to know much about OpenShift, and admins want to make sure the file is there in the container. Let's take a look at the file itself. I already have it. You can see it's just about the database connection. In our container, we're just getting those connection details from the environment variables. And in different namespaces in OpenShift, we'll be passing different values into those variables. So you can have different credentials for your dev, test, and prod environment. We'll cover the details later. Right now, I'm just going to add this file into our folder. And here it is. Now we have our source code. I'm going to GitHub to create a repo. We name it Drupal OpenShift demo. And then we hit the create repository button. Alright, the repo has been created. So I'm going back to my local and commit my source code into the repo. It's all done. If we go back to GitHub and refresh the page, we can see our code there. Now we're going to create a Docker file at the root level of our GitHub repository. As you can see, we're using the Drupal image we created earlier as the base for this new image. So whenever we make a source code change and do a build, the image will get rebuilt and pushed into container. We'll talk about that in more detail later. Now we have our Drupal image ready. We need a web server to run our Drupal site. We're using Nginx as our web server, but you can also use Apache. We plan to put our Nginx into a separate container from the Drupal, but we want them to be in the same pod. That way we have control over both, and they can talk to each other and share the ephemeral storage space. Let's take a look at the Docker file for Nginx. The first section says the base image will be the official Nginx image. The second section creates a folder which will host the site and be shared with the Drupal container on the ephemeral storage space. In the third section, we're copying our Nginx config file into our container image. In the next section, we're changing permissions for various folders. The reason why we're doing that is, in OpenShift you cannot run container as root, but you'll be running container as a user who's in the same group as root. In the last section, we're saying we're using the port 8080, and that's for the same reason. We cannot run container in OpenShift as root, so we have to use a different port. Let's take a quick look at the Nginx config file as well. You can see it's just a regular Nginx config file for a Drupal site. Nginx is simply acting as a web server, and the PHP fast CGI is acting as the application server. But I do want to emphasize, that Nginx needs to talk to the fast CGI through the HTTP, not socket. You cannot use socket because they're in the same pod, but they're in different containers, so they're not sharing the processes. And for SSL, if you want to terminate your SSL session as H-front, you don't have to do anything here. But if you want to do a pass-through and terminate your SSL session in the container itself, then you need to configure the certificates in this config file. Okay, I'm going to build the image out of those files and push it into the integrated repository. And alright, it's in repo now. Next, let's take a look at the database. In our real system, we're running a Petoni database cluster on a stateful set in OpenShift. But for this demonstration, I'm just going to do a simple Postgres container. Let's take a look at the Docker file. You can see it's pretty simple. We just grabbed the official image, added a directory, and changed the permission for that directory. Now I'm going to do a build and push it into our repository. Now we have three image streams in our repo. For the Drupal-based image, the Nginx image, and the Postgres image. We're going to do a build and create a Drupal image. Let's take a look at our build configuration. As you can see, the output image is called Drupal with the tag latest. We specify the requests and limits for the memory, as the build will fail if we don't have enough memory. If you're unfamiliar with the resource requests and limits, please take a look at my previous video on that topic. Our strategy type is Docker, as we have a base image. We're using the image we just pushed earlier as the base. And our source code would be pulled from our GitHub repository. So I'm just adding the URL for the demo project we just created. We will also specify a secret, as we want to use the webhook in GitHub to do automated build. We just go back to the console and paste the contents in there. Now we're going to do a build. And finally, we have our Drupal image ready. Since we have all the images ready, let's put them together. Let's start with database. I created a deployment config for the database. Let's take a look. Remember the environment variables we talked earlier? We're passing them to the container here. You may notice that I used plain text values here. That's just to simplify the demonstration. Never use it with your production. Always use config maps and secrets. Also, I use ephemeral storage space. That's also for the demo. Never use it with your database. Use a persistent volume claim. Now I'm going to apply this config and create the database pod. Okay, the database pod is up and running. We need to create a service for it, so the frontend can call it from the service. So we go to Services and click on Create Service. We want to name it Backend Service. And this is for the demo app. And the ports are 5432. Then we hit on Create. It's created. Let's move on to the frontend. First, we want to create persistent volume claim. This is because Drupal needs to retain files after the pods get restarted. So we go to the persistent volume claim and create a persistent volume claim. We'd go with the default storage class. We will name it frontend PVC. Because we want to do horizontal scaling, and all the frontend pods should share the same storage. However, we don't have that option here. with the provided storage class. So we're using single user mode for this demo, but remember, don't do that in your real system. We give it a gigabyte. For volume mode, we want to keep it to file system, as we're using this storage for file system, not database. It's created. Let's move on to the deployment config. I'm opening my front-end deployment config. We can see we have one ephemeral and one persistent volume here. The first container is Drupal. We're using the image we just built. We're specifying requests and limits for memory. We're passing on the environment variables. Again, you should be using config maps and secrets here. Let's take a look at the post start commands. First, we copy our code into the app folder. Then we create some folder on the persistent storage for Drupal files and use symbolic links to map them to the website. Then we run some drash commands. Please don't run those commands on the initial launch, as the database would not be there. The second container is Nginx, and it shares the volumes with Drupal container. I'm going to apply this. And okay, the pod is up and running. Then we're going to create another service for the frontend. We're going to name it frontend service. And this is for the app demo frontend. We're going to change the target port 8080 as we're running the container on the port 8080. We're going to specify the session affinity to client IP. That'll make sure the incoming traffic is load balanced while the session is maintained. The service is created. We're going to create a route for it. We name it front-end route. Then we choose the service and the target port and create. By the way, I'm creating those components one by one for this demonstration's purpose. But in real world, you want to use template to do so. Now the route is ready. If we click on the link, it'll take us to the Drupal setup page. We just need to follow the instructions to get Drupal installed. It's all done. We have our Drupal site ready. Lastly, I want to show you how to create the webhook. First, we're going to copy the payload URL. Then we're going to GitHub. Open my project. Then we're going to Settings and Webhooks. And click on Add Webhook. We're going to change the contents type to application JSON. Pasting our payload URL. And put in the secret, which is in the URL. And create the webhook. Now, if we make some changes to the main branch and go back to the webhook, click on the recent deliveries, we can see the changes has been delivered to OpenShift automatically. If we go back to OpenShift, we can see a new build has been triggered. The beauty of this approach is that it fully automated the build and deployment process. It makes the lives easier for both developers and admins. Another great gain with this solution is whenever you need to patch your Drupal core or modules, All you have to do is to rebuild your Drupal image. And that's literally one click. It tremendously helps the admins with their day-to-day operations. Alright, that's it for today. Thanks for watching. If you have any questions or suggestions, please leave a comment below. If you like this video and would like to see more videos like this, please subscribe to our channel, Learn Tech with Jack.